So using Excel for the under pressure lab, all you need to do first is put in the data. And as it says here in the data table, you got pressure and volume. Whatever your data is, again, all the data points you can record here. For the pressure here, I'm just typing their numbers in directly as they're written. So that right there is kind of the longest step. Now, the next thing you do is what is called 1 over volume. So I'm just going to type that in here so I know what I'm going to do, 1 over volume. To do the 1 over volume, all you need is, here's the volume initially. So you just say equals 1, and then you highlight the, equals 1, and you highlight the volume, like that. 1 divided by, where's the volume? There we go, 1 over volume. And that gives you the 1 over volume as a decimal. Now, this group, like most groups, whenever you look at 1 over volume, what do? You take 1, you divide it by the volume, you write a fraction. Unfortunately, 1/14 and 1/10 are very hard to graph. They're like impossible to graph. So, in science, we always use decimals so that we can graph the data easier. Fractions are incredibly difficult to graph. So, all we do is we take 1 over volume, make sure you write this as a decimal. Once you have this one done, you just highlight the bottom corner and extend it down, and it does all the rest for you. Okay? You could also press Control Copy and Control Paste multiple times, but I like to save time. The next one is pressure times volume. So pressure times volume. So which one is the pressure? Which column here? A, B, C, or D? B. So I do equals B, and then you do a star, which is Shift 8, and then volume, and then hit Enter. And it calculates that value for you, which agrees with what these guys calculated. You can always double check your Excel work if you really want to, and then you just highlight and put it down, and you got all of them. What this does is it copies the formula for each of these respective rows. So since it copies the formula, here's our data here of pressure times volume. Now, the thing about this data is it says graph 1 is to graph pressure versus volume. So what I'm going to do is highlight these two. If I'm lucky, it will graph exactly what I want. If I'm unlucky, I'll have to switch the two columns. So if you have this version of Excel, you go Insert, Column, Line, Pie, Bar, Area, Scatter, Other Charts. You want a scatter. It's often called an XY scatter. They took off the XY because people didn't know what X and Y were. Because people didn't understand that that's the way graphs are made. But, so you pick scatter, and then you have choices. Okay? You do not want any lines on here. So this is the only one with no lines. You select that. It gives you a graph. Okay? I always delete this because I don't need to know what that is. The title is not quite right because it's not just pressure. It's pressure compared to what? It's pressure versus volume. Now, I double check my numbers. Volume only goes up to 20, so which axis has volume in it? The bottom one, very good. So it matches what I expect. Pressure is on the Y, volume is on the X. You're comparing the two of them. Now, if you look at the data here, does it look like a straight line? Not quite. Close, but it looks a little bit what? A little bit like a curve. So, you got your first graph made here. I didn't label the axes. If I did this, that helps out a little bit. You'll notice this line says it's linear. It's not really linear. It doesn't fit. So it does all this work for me. Now I just need to title this axis. This is pressure, and that's in kPa. Make sure you label your axes with the units. And this one is in volume, and that's in milliliters. So this graph looks a little bit better. Problem is it's not linear. So I'm going to select the trend line, format trend line. Uh-oh, here it is. Here's my forecasting, my equation, my R squared value, and intercept. And these are our trend options. So it's not a straight line, or maybe it's exponential. Select exponential. Looks okay, not great. Select another one, maybe it's a polynomial or power series. See if it's a power series. That's pretty good, not bad. Not perfect, but now the cool thing is, let's see if we can take this power series and extend it backwards. 5 units. That is not bad. And then let's see if we got a different format. What if it was a polynomial? Uh-oh. That matches really well. We'll extend it back 10 periods. All right, now you can see it matches pretty well with the data. But what do you see happens here with the volume? Gets smaller and then it gets into what? Negative. Okay, I got a question for you.
Yes.
Can you have negative volume?
No. Yes.
Nope, can't have negative volume. So we've got a little bit of a problem here. Okay? We've got a little bit of a problem. This graph here, unfortunately, seems to be going into the negative. Maybe if it curves up this way, it wouldn't go into the negative. So what we're going to have to do is we're going to have to see what happens when we do the reciprocal volume versus pressure. So we take these two here, insert, scatter, and uh-oh, I have the wrong columns here. 1 over volume, there's my 1 over volume, there's my pressure. So I'm going to switch these two. Oh, sorry. Alright. So right click on the series. Okay, select data. Alright. And this is 1 over volume. Chart data range. Select that one. So you edit your series by your X value. I realize some of you know how to do this. Please be quiet, because you're not going to know what I'm going to do next. So X values here. You want the 1 over volume to be on the X value. So you can select X values, select these here. Y values are the pressure here. And then delete that one. And why do we have this point here? Oh. So X values, 1 over volume. Y values, pressure. All right, an easier way of doing that is you just move the cells somewhere else in the chart. So here you can see, here's what the data looks like. So if you look at this data, does it look like it is almost a linear relationship? Yeah, but it kind of looks like it has a curve to it. So you can see we have a little bit of a curve to this. And if we extend this backwards, format the trend line backward 10 periods. Oh, that's too far. Too far still? Our units are really small on this one, 0.1. So you can see from the trend line, it's supposed to go through what point do you suspect? It's probably supposed to go through 0. It definitely does not go through 0. So what we need to do is these are our first graphs. Graph 1 is pressure versus volume. That's this one here. Graph 2 is pressure. Pressure versus 1 over volume. So these two graphs, once you've made these two graphs, the next thing to do is to print the graphs. Okay, these are graph number 1 and graph number 2. Okay? But you'll notice this one does not go through 0, 0. We would expect it to go through 0, 0 if it was an inverse relationship. So an inverse relationship means as you increase one, the other decreases. So let's look and see. Oh, move this out of the way. If you look at this curve, please shut up. I'm tired of hearing you talk. If you need to do something else, shut up and do something else. Don't talk. Next thing here is in pressure. As the pressure goes up, what happens to the volume in milliliters? What does the graph tell you? As the pressure goes up, what happens to the volume? As the pressure goes up, the volume goes down. Goes up. As the volume goes up, what happens to the pressure? Goes down. So as the volume goes up, the pressure goes down. As the pressure goes up, the volume goes down. This is known as an inverse relationship. As one goes up, the other goes down. Now, if it's an inverse relationship and it's proportional, if we graph the inverse, it should go through 0, 0 and be a straight line. Does this go through 0, 0? No. So there's something wrong. Something is wrong with our experimental data. So we look here at what we had to measure. Who has a device? If you don't got one here. So, on this device here, what were we measuring the volume of? What were we measuring the volume? What we've seen right now is in this relationship you've seen that pressure and volume are inversely related. However, our data does not exactly prove it because we forgot to count the syringe. We forgot to count the tube, which is perfectly normal. It happens all the time because who would have known that you had to count the actual tube in there? So let's see what we can do for counting the tube. The relationship you just looked at with your data is what is called Boyles Law. Boyles Law says that as the pressure increases, the volume decreases. Pressure and volume are inversely related. As one goes up, the other goes down. In our data, pressure times volume should have been a constant number. One thing we saw is it was not a constant number. It varied quite a bit. We also saw that our line, our pressure versus inverse volume, did not go through 0, 0. So both of these things are a little bit off. So we need to find how much the volume of the tube is. To do this, we use Boyles Law, which says P1V1 equals P2V2. We've had some like this, yes. We had one that was M1V1 equals M2V2. This is molarity and volume are inversely related. This is pressure and volume are inversely related. Now, the cool thing is, all we have to do is rearrange this equation a little bit. Pressure 1 divided by pressure 2 equals volume 2 divided by volume 1. So I just rearranged the equation to put pressure on one side and volume on the other. Now, each of these volumes you measured, you forgot to add the volume of the what? Tube. So I'm going to add it in here. Volume of the tube. Volume of the tube. Now, what things did you measure? You measured pressure. You measured pressure at 2 different points. You measured volume at 2 different points. The things we did not measure are the VT, volume of the tube. So now all we have to do is do a little bit of math and solve for the volume of the tube. So from this group's data, I'm going to use 2 of their data points. Any 2 can be chosen. So pressure 1, I'm going to say pressure 1 is, what should that be, 87, pardon me. So 87 kilopascals. And the volume 1 is 18. Volume 2, I'm going to choose a different one, is going to be 10. And this is going to be 131. So there's our V2, P2, P1, V1. And then you got to add the volume of the tube, which I'm just going to write as V. So now all we have to do is solve for V. So we cross multiply. 131 times 10 plus V equals 87 times 18 times plus V, sorry. We multiply this out, 1310 plus 131V equals whatever 87 times 18 is, plus 87V. So subtract 87V from both sides. And then 87 times 18, whatever that is, subtract 1310 from that side. And this will equal a equation with one variable that you can solve for V. So that's all you have to do. And you may choose any 2 data points. And that will tell you the volume of the tube. Any questions on that mathematical step? So this will tell us the volume inside of the tube. One thing you'll want to do is you'll want to do this for at least 3 data point sets. So don't just choose the first 2 and say, yeah, we're good. Choose multiple sets. I did one from 18 to 10. That's a pretty good range. You might want to do one that's closer to 0 as well. Okay? And then you'll get multiple volumes for what the calculated volume of this tube actually is. And then from that, you should be able to get a volume correction factor. Now, once you have this volume correction factor, I didn't do the math, so I don't know what their volume correction factor is. Once you have this volume correction factor, it might be something like this. Again, maybe the volume is 5 milliliters. This is just completely made up. Did I calculate it? No. Are you going to calculate it? Yes, you want to calculate it. So, once you have that calculated, the last step on your graph is, you already printed these 2. This is graph 1. This is graph 2. Now what you're going to do is you're going to add one more column. This is volume plus correction. So if the correction was 5, I'm going to do equals 5 milliliters plus whatever's there. And then you do the same thing with sending it down. Now I've got new volume data. Okay? Now the really cool thing is if you've got the new volume data, let's see if we can get this to work here easily. You select data. You got your pressure data and your volume data. Let's see, the horizontal 20. So this one. Hide that one. That works pretty good. Whoa, that was cool. What did it do? That's cool. Oh, let's see if I can. Up, just did pressure versus pressure. All right. So what I'm going to do is just delete that. Well, I don't want to delete the whole thing. See if we can expand this. There we go. Oh, there we go. There we go. And here we can see the relationship. Looks a little bit better, but it's hard to tell. With the graph, it looks like it might be more exponential. No, still polynomial. Maybe a power series. That looks pretty good. A little off. All right. So once you have this here, then you can correct the data down here. Your 1 over volume is no longer correct. So what you can do is you take your 1 over volume, instead of it being at a B2, you click on this and switch it to A2. And these will change your 1 over volume values. And then your P times volume is also times A2 now. And then you extend that down. And you'll notice, look at all these numbers here. Are all these numbers very close to the same thing? The answer is yes or no. They're pretty close. They're not exactly the same, but they're pretty close. So you can see they're much closer than 1,600 and 1,000. So they're all within about 100 points. They're not exactly the same. You can definitely see that. And if you look at our graph changed. Did it go through 0, 0? Nope, but very, very close. So this correction factor, remember, I just made up the correction factor. If I really would have known the correction factor, this probably would have been almost right on the dot. So what you're going to do is you're going to graph the two original graphs, and then 2 corrected graphs. So original graphs, then corrected graphs. There will be a total of 4 graphs to do. I'll give you some time to work on those graphs in lesson 11 now while you are working. If you want to go into the room next door and work on the graphs, you're able to do that. If you want to wait until you get home, you're able to do